Hey, it's been a while. I took a break from my larger game project to work on the game you see here for a few weeks. I really just wanted to finish something small and straightforward for a change, so I decided to take an old game jam submission which was implemented in Unity at the time and port it to Godot. And of course improve on the prototype. It's a tiny 2D game about evolution and the circle of life, where you play as a sea creature traveling from the bottom of the sea to the surface, feeding, reproducing and evolving. By now I have released this as a free browser game, so if you'd like to try it out, there will be a link in the description. In this video I want to share a few insights from carrying the project over from Unity to Godot. Let's get started. For 2D games, one big difference between Godot and Unity is the coordinate system. In Unity, a 2D game is treated more or less like 3D, where you simply ignore the Z-axis. When you place your camera at the origin, that will be at the center of the game window, and the Y-axis points up on the screen. Units can be whatever you choose, for instance 1 unit equals 1 meter. In contrast, Godot uses pixel coordinates, so 1 unit is 1 pixel. The origin is in the upper left corner of the screen and the Y-axis points down. Godot does have some flexibility in mapping these coordinates to the screen, however. There is the stretch mode in the project settings, which defines how the project's base viewport size is mapped to the actual screen. And of course, if you add a camera 2D to your scene, you can pan and zoom into your scene. Scenes in both Unity and Godot are composed as a tree of nodes. There are differences in how you attach functionality to these nodes, however. In Unity, every node in the tree is a game object. Each game object has a transformation matrix, so its closest equivalent in Godot would be a node 2D. All other functionality is added to a game object as a component. For instance, you can add a sprite renderer component, a rigid body component, a collider, a script, and so on. In Godot, all of these are represented by their own node types, which you add as children to a root node. A script is directly attached to a node in Godot, effectively creating a subclass of that node type. This example here shows a class hierarchy where player control extends creature base, which in turn extends Godot's built-in node type rigid body 2D. In Unity, you might have an object like this with a sprite renderer as a component and one or more scripts attached to the same game object, also as components. To access the sprite component from script, you use getComponent like this. In Godot, you'd rather have a root node with an attached script and a sprite node as a child. And you address the sprite using getNode or the shorthand $sprite. So this requires some reorganization when porting from Unity to Godot. Here is another major difference between Unity and Godot. A prefab in Unity is a self-contained game object or a whole tree of objects that can be instantiated anywhere in the main scene. You can also create variations of such a prefab to modify some of its properties. Changes can be made in the prefab itself and also at the place where it is instantiated in the main tree. I just recently learned that you can do something similar in Godot by using the editable children feature. Let's say we create a simple scene with a sprite here. Let's call it prefab because that is how we will use it. We can create instances of the scene as usual. And the magic happens when we activate the editable children from the context menu. Now we can manipulate properties in the instantiated scene and even add nodes. For example, let's add another sprite here. The cool thing is we can go back to the original scene file, make modifications, and they will be propagated to the edited instances of that scene in the main tree. So in Godot, basically any scene can become a prefab. You cannot directly create prefab variants as in Unity, but I guess you could save the edited instance of the scene as another scene asset and then instantiate that. Not sure how well this works if you make modifications in several places. I haven't personally tried. Let me know in the comments if you have more experience here, I'm curious. This is a more general concept, but colliders are a really great example. In Unity, a collision handler looks like this, where a collider2D is passed as an argument to the function. This in Unity is a component on a GameObject. From one component we can easily get any other component in the same GameObject, such as the floating particle script component here. And here's the GameObject structure. You can see the script and the collider component are part of the same object. Now in Godot, a collision handler receives the colliding area, which is a node somewhere in the scene that holds the script we want to get. Assuming the script is attached to the root node of the scene, here's a handy trick. The owner property of any node in a packed scene points, by default, to the scene's root node. And since the script subclasses that node, the area's owner effectively is a reference to the script already. Let's have a quick look at the scene I'm talking about. Here's the area that is passed to the collision handler in the script we just saw. And here you can see that the attached script indeed derives from floating particle as expected in the code. My game uses a little bit of physics. The player is a rigid body 2D and there are some colliders in the scene. I'm happy to say that there isn't much to say here. Porting this was really straightforward. The rigid body component became a rigid body 2D node. Forces had to be scaled to adjust for the different world units. Then linear drag became linear damp and so on. Updates to the forces in Unity should be done in the fixed update function, and that corresponds to the physics process function in Godot. The one thing that I found a little annoying was again collisions. In Godot, physics collisions and general area overlaps use separate collision shapes. If we look at the signals provided by rigid body 2D, we see that only collisions with other physics bodies can be handled here. For collision handling with non-physics objects, we need an area 2D, which has to have its own collision shape. Now, I said I was annoyed by this. On the other hand, you could see it as an advantage. I actually ended up wanting slightly different shapes for physics and general overlap detection, so it did work out well in the end. Let's go over some smaller bits and pieces I found interesting. In Unity there's a handy way to enable or disable a game object completely, with the setActive function. setActive completely deactivates the object. It's not rendering and update is not called on scripts anymore. In Godot, you can achieve that by setting the visible and the process mode properties. So here's a little function that I'm now using all the time. This is somewhat related to pausing the game. In Unity, I pause a game by freezing time, by setting the time scale to 0. Scripts are still updating when you do this though. Godot has a very nice explicit pause mechanism built in, which not only freezes time, but also generally stops processing of scripts. You can have specific nodes processing while paused, for example to keep your pause menu running, by setting process mode to paused or always. Here is an invitation to off by 1 errors. This one did cause a few hard to detect bugs when porting my game, so watch out. Unity's random range function for integers has an exclusive upper limit. The equivalent function in Godot is inclusive. So you'll have to subtract 1 from the second argument. Yeah, and that is pretty much all I found noteworthy. At least for this 2D game, porting from Unity wasn't too hard. And I have to admit, it was a lot more fun to work further on the game once I had it running in Godot. There is more to say on building for the web and supporting desktop and touch devices in the same program. I will probably make another video about that sometime. So keep making games and see you soon. Bye!